Let's learn about Le Chatelier's principle, which basically states that if you have a reaction that's in equilibrium, and that equilibrium is disturbed in some way, like for example, the concentrations of the reactants or the products are changed, then the system is going to shift, or that reaction is going to shift in the direction, either the forward direction or the reverse direction, to reestablish equilibrium, okay? So we need to talk about three different scenarios that are commonly tested using Le Chatelier's principle. The first is if you have like an aqueous reaction, a reaction occurring in solution, and you're changing concentrations of reactants and products. So here we have this reaction where basically iron, okay, reacts with thiocyanate, right? And that forms iron thiocyanate. So what happens in this case if we increase the concentration when this reaction is at equilibrium of the iron, right? So what is iron here? Well, iron is going to be a reactant, right? It's a reactant. So if you increase the reactant concentration, then you want to produce more product, okay? Because then the ratio basically of products to reactants has decreased, right, compared to equilibrium. So if you add more reactants, then you should be producing more products, so that that ratio goes back to what it should be at equilibrium. So this is going to shift the reaction towards products. Now, if you reduce the amount of reactant, then you're going to shift it in the reverse direction to reform some of those reactants, okay? So that ratio is reestablished. So decreasing the number of reactants, or the concentration of a reactant, would shift this reaction in the reverse direction back towards reactants, okay, to form more reactants. What if we do it with the product? So if we increase the concentration of a product, okay, now we have more products than we should at equilibrium. So the reaction shifts in the reverse to use up some of those products and form more reactants. So this will shift it towards the reactant side, R. Now, if we decrease the concentration of a product, now we have fewer products than we should at equilibrium. So the reaction shifts in the forward direction to produce more products, okay? So this is going to go to products. Now, the second situation is if we have a reaction involving gases, okay? So here we have nitrogen gas reacting with 3 molecules of hydrogen gas, and that produces ammonia gas, okay? So here, Le Chatelier's principle is often tested in the context of changing pressure and volume. And remember that at a constant temperature, pressure and volume are inversely related according to Boyle's law. So if we increase pressure, we're going to decrease volume. And what you can think about happening there in terms of gases is that you're essentially making it so there's less room for the gas molecules. So a reaction involving gases that's at equilibrium, if you like increase the pressure, decrease the volume, what will happen is it will shift to the side that has fewer moles of gas. Okay, so how many moles of gas are on the left side? Okay, well, on the left side, there's 4, 1 nitrogen, 3 hydrogens, okay? Whereas on the right side, the product side, there's 2. So in this case, if you increase the pressure, you're going to shift the reaction towards the product side, okay? Now, remember though, this depends on the reaction. So if we were actually producing more moles of gas here, like if we were producing like 5 moles of gas and we started with 4, then in that case, the reaction would actually shift towards the reactants, okay? So it's reaction specific. Now, if we decrease the pressure and increase the volume, then we basically have like more room for moles of gas, okay? So in that situation, the reaction will shift in the direction that produces more moles of gas, in this case, in the reverse direction, okay? But when you have a system of gases and you get like a question on Le Chatelier's principle with changing pressure and volume, make sure you know how many moles of gas are on each side and decide based on that. The last application of Le Chatelier's principle involves changes in temperatures when you have a reaction that's exothermic or endothermic at equilibrium. So here we have this reaction where dinitrogen tetraoxide decomposes into nitrogen dioxide. And we are told that this reaction has a delta H and enthalpy change that is positive, okay? Now the number is not exact, I just made that up, but it's positive. What does that mean? It means it's endothermic. So it requires heat to proceed in the forward direction. So in this case, I want you to think of heat as being a reactant, okay? So if you increase the temperature, you're essentially adding more heat and therefore more reactants if the reaction is endothermic. So what happens if we increase temperature in terms of Le Chatelier's principle? Well, the reaction, right, is going to shift to favor the product side, right? The product side, okay? Now, if we decrease the temperature for an endothermic reaction, then it's like we're decreasing the number of reactants, okay? So then the reaction shifts in the reverse direction to favor the reactant side, right? So then this shifts towards the reactants. But let's say, hypothetically, that this reaction was not endothermic. Let's say it was exothermic, so it's negative, right? Well, what would happen if we increase temperature now, if it's exothermic? Well, exothermic means that heat is produced. It's a product. So if we increase temperature, we're adding more product in that case, and then the reaction will actually shift towards the reactant side. But if we decrease the temperature for an exothermic reaction, we're removing product effectively, we're removing heat, so the reaction shifts in the forward direction to produce more. So then for an exothermic reaction, decreasing temperature favors the product side. I'd like to invite you to my live workshop, which I'm hosting tomorrow, Thursday, June the 5th at 8 p.m. EST and 5 p.m. PST. In this workshop, I'm going to be teaching you my top 5 strategies for achieving a 516 plus on the MCAT. And these are strategies which I've developed and honed over the last years of teaching many students taking the MCAT. Now, if you're interested, please send us a DM and leave a comment, and we will send you a link. It's completely free, and I really hope to see you there.